my comment was, what's different about section 2.7 and the other sections in the chapter is now our equations or our inequalities are all going to have some of these in them, absolute values. And so how is that going to change the way I go about solving them? Finding all the values of x that makes those statements true. So you could think of this section as absolute value equations and inequalities. We're going to have 3 different scenarios that we have to think through. So let's deal first with absolute value equations. And while you guys are writing that, I'm going to see if the volume's working like it's supposed to, because it didn't on the last one I did yesterday. So give me a second here. So an instance like this would be if I had, for instance, say the absolute value of 3x minus 8 is equal to 12. So I'm going to think about what values of x make that true. Now, what we're going to do is we're going to create a model for solving absolute value equations. So we'll do that beneath this line here. And to establish that model, we're going to go over here and do some thinking. So what I do over here doesn't need to be in your notes. Okay? So let's think through this for a minute. If I said to you the absolute value of y is equal to 6, and I said, what could y be to make that statement true? I'd be asking you, what can you take the absolute value of that would give you 6? So what can you take the absolute value of to give you 6? 6 is certainly the case. The absolute value of 6 is 6. Is that the only thing?
2 times 3. No,
negative 6 is the only other thing. I mean, 2 times 3 is the same thing as 6.
Okay, so you do a bunch of different.
No, I'm just thinking about what can I put in here that would make this statement true. If I put a 6 in there, the absolute value of 6 is 6, so that'd be true. And now Salvador and Josh are telling me if I put negative 6 in there, the absolute value of negative 6 is also 6, isn't it? So what does that mean for me? If I have the absolute value of y equal to 6, that means either y could be 6 or it could be negative 6. Either way, the absolute value of y is equal to 6. That's what we're saying. Now, we're going to have equations like this today. The absolute value of ax plus b equal to c. So we're going after the model here now. So, using the same logic as we used over here, just like if the absolute value of y was equal to 6, that means y could be 6 or it could be negative 6. If the absolute value of ax plus b is equal to c, then what does that mean for ax plus b? Oh, crud. Well, couldn't ax plus b be equal to c? And that would make the statement true? Or ax plus b could be equal to negative c, and that would also make the statement true either way. Because if I take the absolute value of something equal to c or something equal to negative c, either one, I'm going to get c. So whenever I see this, whenever I see absolute value of an something equal to c, this is how I'm going to handle it. I call this strategy split it up. Bless you. By the way, you're not going to see that referenced in your book or anything. That's my terminology. So, how's that going to flesh out on the problem that we started with then? Which was the absolute value of 3x minus 8 is equal to 12. What am I going to do here? I'm going to split that up. That means 3x minus 8 could be equal to 12, or 3x minus 8 could be equal to negative 12. Haley, does that make sense to you what I'm doing there?
Yeah.
Okay. And I'll solve both of those and I'll have two different solutions for my equation. So here, we're going to add 8. And 3x will equal 20. And we're going to divide by 3. And x will be equal to 20/3. There's one solution. Over here, we're going to add 8. Those will cancel. 3x will equal negative 4. And we'll divide by 3. And x will equal negative 4/3. So you say, well, how are both of those answers? How can they both be answers? Well, if you put 20/3 in here for x, then you'll end up with 12, and the absolute value of 12 is 12. If you put negative 4/3 in here for x, you'll end up with negative 12, and the absolute value of negative 12 is also 12. That's how they both work. Are we making any sense here, class?
Yes.
Okay, so what I want to do now is I want you guys to try one. So, the problemo I would like for you to try, is the absolute value of x minus 3 is equal to 7. David Black got 10 and negative 4 because we would split it up, x minus 3 equals 7, x minus 3 equals negative 7, and solve both of those. By the way, our 2 minutes is up. Now, one last thing I want to comment to you about absolute value equations, and this is going to hold for our other problems as well. If you get a problemo, like say this, the absolute value of x minus 2, and then let's say something's added to it, plus 3 is equal to 15. Now that does not fit our model right now, because look at our model. Our model has an absolute value over here and then a constant over there and nothing else, right? So we've got to make it fit our model before we split it up. In other words, the absolute value part has to be by itself first. So let's see if you understand what I just said to you. With that in mind, what would that mean my first step here would be? Yeah, I got to subtract the 3 from both sides. Then I'll have the absolute value of x minus 2 by itself. And on the other side, I'd have 12. And now you can split it up. And then you can finish it from there. So if you see any of that, make sure you get the absolute value by itself first. Head shakes? Head shakes. Good, good. Okay. Rock and roll. Oops, that's not what I meant to happen. I think it was the band Kiss who said, I want to rock and roll all night and party every day. Well, you know what, Kiss? Get a job. Because I think you'll feel better about yourself. Well, anyway. All right, the next thing we're going to do is we're going to discuss absolute value problems with less than or equal to. So an example of this kind of problem would be something like this. The absolute value of 4x plus 1 is less than or equal to 21. So we'll come up with a model again. So what we're going to try to do is come up with a model for if I have the absolute value of something like ax plus b is less than some number, c. And to develop that model, we'll go over here again to our other box and we'll do some thinking. So this stuff over here, you really don't need in your notes, we're just thinking. Let's say I said that the absolute value of y was less than 3. And this time I'm going to look at a number line. And we're going to think about all the things that I could take the absolute value of and get something less than 3. So, hang on here a minute. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 5, negative 4, negative 3, negative 2, negative 1. I'm out of space, but you get the idea. Okay. Now, my little turtle is going to crawl back here. It's going to make a green line. See that? So if my little turtle was crawling back over here over negative 5 and negative 4, are those values that I could take the absolute value of and get something smaller than 3?
No.
Okay, I got one head shake yes and one verbal no.
No, because then it's an absolute value.
What's the absolute value of negative 5?
5.
Is that smaller than 3? No. Is the absolute value of negative 4 smaller than 3? No. I'm not going to do any good until I hit negative 3 and then get to the other side of it, right? So that's going to be a key spot. Now, is the absolute value of negative 2 less than 3?
Yes.
What about negative 1 and 0?
Yes.
Yes. What about 1, 2, and 3? Or how about 0, 1, and 2, I should say? Yes.
Yes.
I'm going to be good until I hit what? Until I hit 3. When I hit 3 and go out here to 4, 5, and 6, now the absolute value of 4 is 4. That's not less than 3. The absolute value of 5 is 5. That's not less than 3. So really, I would be looking at everything from negative 3 to positive 3, right? In other words, that means that y would have to be less than 3, but it'd have to be greater than negative 3. You see that? Those values would be the ones I'd be after. Now, what does that mean for us? Using the same logic then. If the absolute value of ax plus b was less than c, then what would that mean about ax plus b? It would have to be between what two values? C and what? C and negative c. Using the same logic. So that's the model we'll use for absolute value with less than. I call that a sandwich. So if it's absolute value with less than, we're going to make a sandwich. Kind of sounds good, doesn't it? Hey, tomorrow, now this would be Saturday. Okay, so let's go back to our original problem.
Have in mind of the food now.
Which was the absolute value of 4x, and I don't remember. What else was it?
Plus 1.
Is what, less than or equal to?
Yep.
21. Okay, so using this as our model, what would we do? We'd make a sandwich. So we'd say negative 21 is less than or equal to 4x plus 1 is less than or equal to 21. And then we'd solve that. Like we did yesterday. This is another compound inequality. Haley and Josh, what's my next move as far as getting the x by itself is concerned?
Rid of the 1.
Okay, subtract 1 from all three sides. So if I do that, negative 22 is less than or equal to 4x is less than or equal to 20. Somebody in Anna, tell me what's next. Divide by 4. Am I flipping signs?
No.
Nope, because I'm dividing by positive 4. Now 22 over 4, those are both reduced by 2 and make negative 11 halves is less than or equal to x. And 20 over 4 is 5. So here's our answer in set builder notation. Now, stop for a minute. Do you see that an absolute value problem with less than is an intersection? It's a conjunction. That's why we studied what we did yesterday. We talked about how to graph these. 4x plus 1 has to be both greater than or equal to negative 21 and less than or equal to 21 at the same time. It makes it a conjunction, which makes it an intersection. So, in your problems, guess what? They're going to ask you to find the solution. They're going to ask you to graph it. And they're going to ask for interval notation. So let's get after it. 0, 1, 2, 3, 4, 5 is right there. Boom, boom, boom. How about 11 halves as a mixed number? Be 5.5, wouldn't it? 2 goes into 11 5 times, and you have 1 left over. So negative 1, 2, 3, 4. There's negative 5. Here's negative 6, so negative 11 halves is going to be right in between those two. So in this case, they're both going to get a bracket because we have less than or equal to. So a bracket at negative 11 halves. A bracket at positive 5 and shade in between. And in interval notation, that'd be negative 11 halves with a bracket and 5 with a bracket and ball game. So what does that mean? It means any number including negative 11 halves and between negative 11 halves and 5 and including 5, any number you pick on that interval and substitute it in the original problem, it would make it hold true. Okay, any number outside of that interval, it would not hold true. Okay, I think that you guys should practice one of these. So, why don't you go to work on the absolute value of 7x minus 2 is less than 5. Did you get negative 3/7 less than x less than 1?
I wrote it as 0.42.
Okay, all right, I can live with that. Now, did your graph look something like that? Negative 3/7, you just said it's negative 0.42, so it's a little bit less than halfway to negative 1. And then over here, 1's going to get a parenthesis. And in interval notation, they both get parentheses. So, what have we said so far? In equation problem, we're going to split it up. An absolute value problem with less than, we're going to make a sandwich. And we have one more scenario to talk through, and that's absolute value with greater than. Or greater than or equal to. And you can't, what happened? I'm frozen, you can't see anything, it's not good. That means we're going to have to shut down. Nope, we're not going to have to shut down. There we go. So a problem like this would be if I had the absolute value of 2x plus 1 is greater than 7. So we're going to create a model for that. So that model is going to look something like this. The absolute value of ax plus b is greater than c. And so let's think through that model. And to do that, we're going to go back up here to this number line we had a moment ago. It was this one. It was this number line, although it's kind of messy. So maybe I'll semi-start over again. What if that would have said, instead of the absolute value of y is less than 3, what if it would have said the absolute value of y is greater than 3? Okay, now let's think about the number line. These values that I had before, that I'm marking in yellow now, none of those are going to work because the absolute value of negative 2 is not greater than 3. Absolute value of positive 2 is not greater than 3. None of those are going to work. The ones that would work are all these values that are bigger than 3, the absolute value of 4, 5, or 6, or 7, those are all greater than 3, right? Or if I'm smaller than negative 3, the absolute value of negative 4 or negative 5, those are greater than 3. So, to make this statement true, one of two things has to be true. If we're looking back here, that means y would be less than negative 3. That would make it true. Anything less than negative 3, if I take the absolute value, I get something greater than 3. Or if I look at this part over here, it would mean that y would have to be greater than positive 3. Now, did you hear the word or? If either one of these two things is true, if y is less than negative 3, or if y is greater than 3, then when I take the absolute value, I'm going to get something greater than 3. What am I getting at? Absolute value with greater than is a disjunction, which makes it a union. And what did I do? Notice here, I'm going to make two statements again, so this is going to be another split it up problem. One statement is, what's in here? Keep the sign, keep this number, y greater than 3. The other statement is, keep what's in here, y, flip this sign, less than, flip the sign over here, -3. So there's your model right there. If you have the absolute value of ax plus b greater than c, what that's going to mean is either ax plus b is less than -c, flip the sign and flip the sign on the c, or, it's going to be an or problem, ax plus b is greater than positive c. So in other words, we're splitting it up again, just like we did the equations. We're splitting it up. The only thing we got to remember is that on the negative, we have to flip the inequality sign. So absolute value with equals is split it up. Absolute value with less than is sandwich. Absolute value with greater than is split it up. Let's try one. Let's go back to red. The absolute value of t plus 2 is greater than or equal to 10. So because it's a greater than problem, it's a split it up problem. So what does that mean? T plus 2 is less than or equal to -10, or is a very important word. You cannot leave it out. You want to put it in there. T plus 2 is greater than or equal to +10. And we'll solve those separately. If I subtract 2, I'd have t less than or equal to -12. If I subtract 2 over here, I'll have t greater than or equal to 8. So here's our answer in set builder notation. It's the set t such that t is less than or equal to -12, or t is greater than or equal to 8. Okay, graphically, that's a union. So we're going to include everything on the graph. So if here's 0, let's say 8's out here, and -12 is back here. Then I would have a bracket at -12 and shade to the left. And a bracket at +8 and shade to the right. Okay, you guys go ahead and write the interval notation, and then we'll compare notes. Okay, Jerica or Haley, what does interval notation look like for this problem?
Would it be bracket 8, -12 bracket? Is that right? Yeah.
Okay, it's not right. Let me explain why. First of all, in interval notation, the smaller number always has to come first.
Oh, and it's -12. I'm sorry.
That's okay. That's okay. So you would be thinking this way, but this one's not even that. That's what it would be Haley, if I had shaded in between the two? It'd be everything from negative 12 to 8.
Would it be two different, would it be two with like a negative infinity and a positive infinity?
There you go. That's right. So, what is this first one? What's this side over here? What's that going to look like?
Negative infinity with negative 12.
Okay,
The infinity having a parenthesis sign.
right. And negative 12 gets a bracket. Okay, Jericho, what's this part over here going to look like?
Would it be 8 with a bracket and then positive infinity with a parenthesis?
That's right. And then, Haley, you weren't here for this yesterday, but class, what did we say we do with the word or in interval notation? We need the little union sign between them. That makes sure that we get both of them. Okay. There you go. Now, all this split it up and sandwich stuff, it only occurs on problems that have absolute value. So if it doesn't have absolute value, you don't worry about it. You just solve it straight up. If it's got absolute value, then you have to do one of those two things. Split it up or do a sandwich. Questions or comments from the class relative to 2.7? Does that seem easy, moderate, or hard? Okay, that's good. I'm going to tell you that these are some of the most missed problems on the test. Now, I don't think they're missed because they're hard. I think usually when they're missed due to lack of preparation because students forget to split up or do sandwich when they see absolute value. And that's just a matter of practice. Okay, here is what you can work on from 2.7 class. Your assignment will begin on page 118. Nine through 14 are good equation problems. 27 through 32, bless you, are good greater than problems. '43 through 48 are good less than problems. And 51 through 53, they mix them up. They throw some equations in, they throw some greater thans in, they throw some less thans in. So there you go. That's a wrap on 2.7.